In this video, we're going to find two different parameterizations for a paraboloid. And part of the reason for doing this is just to get practice finding parameterizations. But part of it is to illustrate that there's not one parameterization. There's really nothing unique about parameterizations. Okay, so find a parameterization of the paraboloid z equals x squared plus y squared. After you do that, find the parameterization for the portion of the paraboloid above the rectangle. And we're going to do the first part first and the second part second. Okay, so we want to find a parameterization of the paraboloid. So this is similar to when we found the parameterization of the parabola. So remember, when we found the parameterization of the parabola, it was just r of t is equal to t comma t squared. Well, that was because the curve was the graph of a function, and we have something similar here. So r of st is just going to be st s squared plus t squared. So the x and y components are s and t, and then the z component is just the x component squared plus the y component squared, so that's s squared plus t squared. This is very straightforward. This is for the first part of the problem. And so the parameter domain, you should be in the habit of always defining what the parameter domain is. So s and t, where minus infinity is less than s is less than positive infinity, and then minus infinity less than t less than positive infinity. So in other words, all of the s and t values. This gives the whole paraboloid. So now if we do the second part where we want to add in this condition where we just want the part that is above this rectangle, well, all we do is just restrict the parameters to lie in that rectangle. So r of st is going to be the same parameterization, st s squared plus t squared, but now we just restrict the parameter domain. The parameter domain is just going to be the square, or the rectangle, 0, 2, cross 1, 2, or if we write it in set notation like this is just going to be all of the parameters s comma t, where s is between 0 and 2. Why do I keep writing t there? S is between 0 and 2, and t is between 1 and 2. Like this. Okay. So nothing too complicated there. And in fact, more generally, let me switch colors here and come to the side. When we know that z is a function of x and y, then the parameterization for this surface, or a parameterization for this surface, is r of st is equal to st f of st. It's also okay, technically, to use x and y as the parameters, but I just prefer using s and t as the parameters just because it lets me know this is a parameterization. You do it however you want to. I just prefer using s and t for parameters. Okay, and so now let's do this next part. So find the parameterization of the paraboloid z equals x squared plus y squared. After you do that, find the parameterization of the portion of the paraboloid over the disk of radius 1 centered at the origin. Okay, so there's two ways we could do this. We could just do it like we did it before. We could say r of st is equal to st s squared plus t squared, and now we'll just say the parameter domain. What is a parameter domain? Well, s comma t such that s squared plus t squared is less than or equal to 1, because we want it inside the disk of radius 1 centered at the origin. That's what this does. And there's various ways to write this. There's different ways we could write this. Okay. But notice that maybe Cartesian coordinates aren't the best. Maybe we should be working with cylindrical coordinates. So remember that in cylindrical coordinates, x is equal to s cosine theta. I'm using s instead of r because r is what I'm using for the parameterization. Y is equal to s times sine theta, and then z is just equal to z. So then r of s theta, actually I want to write theta s, r of theta s is going to be x, which is s cosine theta, s sine theta, and z is equal to x squared plus y squared, so that is just s squared in cylindrical coordinates. And now if you want the whole paraboloid, the parameter domain is just going to be theta and s, where theta goes between 0 and 2 pi. S is non-negative. That's for the whole paraboloid. And if we just want the paraboloid that's above this circle of radius 1 centered at the origin, or the disk of radius 1 centered at the origin, this is going to be theta comma s. Theta is still going to be the same. Theta is going to go between 0 and 2 pi. But now s is just going to go from 0 to 1. Okay, and so now if we parameterize the paraboloid using cylindrical coordinates, it's a lot easier to come up with a parameter domain that, say, restricts it to the part that lies in the first quadrant inside the disk of radius 1, or the part that lies above the annulus with inner radius 1 and outer radius 2 and stuff like that.